Welcome to math classes. As I mentioned in the beginning of the year, I am starting now the classes for 11th and 12th, and I just mentioned JEE here. Okay, it does not meant to be only JEE. These classes are useful for every engineering entrance exam. Okay, so first we'll cover the sets in this. Okay, then we'll do relations separately, another video, and then functions another video, which will cover all the three sets, relations, and functions. Okay, which is the very basic for all your other classes. Okay, and I will definitely take up all the tough questions here. I'm not going to do the easy basic questions from the boards or exams. Okay, I'll take the tough questions, variety of questions, and then explain the new concepts. If anything is available, I will explain all those things. Okay, and then more onto the practice. Okay, so along with these videos, I will also put the easy problems in the shorts. Okay, so check the shorts also. It will be titled mostly with the engineering entrance, JEE, something like that. Okay, class 11th and 12th. Okay, so those shorts also are useful. Uh, to go through the easier questions, and most of the questions in this engineering entrance are objective type questions which are meant to be solved in 1 minute. So questions will be tricky but easy to solve, so please also go through my charts. Okay, so let's get into the sets. Okay, this is meant for class 11th and 12th. Definitely class 10th students can definitely see these sets. It is useful. Yeah, nothing wrong with them. There are few concepts which are more than 10th class student actually. Otherwise, if you are preparing for Olympiad, definitely you can go through this. Okay, yeah, set theory. Set is a collection of well-defined elements or objects. The elements of set are considered distinct. Okay, so there is no repetition. They are distinct. Okay, the important term is and well-defined. Okay, they cannot be terms like all wise people in the class. Okay, all healthy people in the country. You cannot define a set like that. Set should be a well-defined. Okay, you can mention all citizens who pay tax. So that is a well-defined uh, element. Okay, that can be a set, but healthy people in the country, that is definitely not. And they are considered distinct. Okay, so that means there is no repetition of elements within the set. Okay, I'm not going through complete details of the set, that you can go through any book you take. Okay, I will define the key definitions here, and then get into the problems. Okay, singleton set. Okay, which means there is only one element in the set. Empty or null set, there is no element in the set. It is represented by either this way. Okay, empty brackets here, flower brackets are 5, denoted by 5. Okay, subset is the set which has less number of elements from the main set. Okay, so if A is a subset of B, when all the elements of set A belongs to set B, all the elements of set A belongs to set B. So set B may have either same as set A, okay, same elements as set A, or it can have more than what set A has. Okay, but all the elements in set A are present in set B. Okay, it is represented with this symbol. Okay, this is subset or equal. Okay, so if you take 1 comma 2 a set, this set is subset of A. A is 1 and 1 comma 2 comma 3. Okay, proper subset. Okay, so if you see in subsets, you have 5. Null set also a subset of a set, as well as the same set, 1 comma 2 comma 3. That is, A is a subset of A itself. Okay, so a proper subset is defined as a set which has all the subsets as elements without phi and itself. Okay, so which means if you have B as 2 3 5, A as then 2 comma 5 is a proper subset of B. Okay, 2 comma 3 comma 5 is not a proper subset of B. Phi is not a proper subset of B. Okay, power set. Okay, power set is a set of collection of all subsets of the set. If A is a set, P of A signifies the power set. Okay, the number of elements contained by any power set can be calculated by n equal to number equal to 2 to the power of n, where n is this is wrong actually, 2 to the power of n is the number of elements in the set. Okay, so if you consider 1 comma 2 as a set, then power of a contains 5 null set, 1 element, set with element 1, set with element 2, set with element 1 comma 2. So total 1 2 3 4, 2 to the power of 2 is 4. Okay, next. A finite set is a set which has finite number of elements which are countable. Okay, like 2 comma 4 comma 6 comma 8 10. Okay, infinite set is a set of natural numbers, set of whole numbers, set of rational numbers. These are infinite sets. Okay, there is no end to the uh, number series, right? Okay, universal set. Universal set is a superset of all the sets being considered. Okay, that means if you are, let's say, working with all even numbers, okay, you're working with set of even numbers, then your universal set is set of natural numbers, set of whole numbers, it can be set of rational numbers. Okay, depending on your problem, universal set will be defined, and universal set is the superset of all the sets considered in that problem. Okay, it is denoted by either S or mu. So U or mu. Equal sets. Okay, if P is subset of Q and Q is subset of P, then we can call P equal to Q. Okay, operations on sets. Okay, what are the possible operations on the sets? Difference of two sets A minus B, which means element is present in A but not in B. Intersection of two sets, element is present in both A and B. Okay, note down the word and. Okay, this is the and operation. Okay. Similarly, union of two sets is element present in A or B. Okay. Note down the R. Union is R condition. Okay. R operation. Complement of a set. Okay. A dash, it's called A dash. A dash is defined as universal set minus A, which means in words, if I mention, it is all the elements which are not present in A. Okay. How do you get all the elements? Uh, okay. Universal set is your standard, right? So universal set minus A. Cartesian product of sets, it is denoted as A cross B. Let's uh, understand this. Let us assume there are two non-empty sets M and N, so that Cartesian product of M and N is denoted as M cross N equal to A comma B, such that A belongs to M, B belongs to N. Okay. So as an example, if M equal to M and N equal to I comma J, then M cross N is M comma I and M comma J. Okay, so how many number of elements are possible in Cartesian product? Okay, product of number of elements in each set. Okay, that is 1 into 2 in this case, which is 2. Okay, symmetric difference of two sets is denoted as A delta B, which is nothing but A minus B union B minus A. Okay, elements present only in A union elements present in only B. Okay, next, some properties of sets. Uh, a commutative property P union Q is equal to Q union P and P intersection Q equal to Q intersection P. Associative, we know what is it. Then idempotent law and law of null and universal set. Okay. So idempotent is I, basically in your addition you have I value, right? Identity number. Similar to that, idempotent element is an element which when operated by itself gives itself as a result. So P union P is P, P intersection P is P. So this is called idempotent. Okay. P union P dash. Now this is law of null and universal set I'm talking about. P union P dash is P dash union P equal to universal set. Means all the elements which are in P union with are all the elements which are not in P. That means it is a universal set. Okay. P intersection with P dash. Okay. All elements in P, all elements not in P. Obviously there is no common element, so it is 5. 5 dash is U, universal set, and U dash is 5. Okay. Next. De Morgan's law. Yeah, this is important actually. P union Q dash whole dash is equal to P dash intersection Q dash, and P intersection Q whole dash is equal to P dash union Q dash. Distributive property, P union Q intersection R is equal to, okay, the union is operated on both Q and R. How it will be operated? P union Q intersection with P union R. Similarly, P intersection union R is equal to P intersection Q union P intersection R. Okay, complement law. We know this already. P dash is equal to U minus P. Okay, P dash minus Q dash. Okay, P dash minus Q dash will become Q minus P. Reverse basically. P dash is elements not in P minus elements not in Q. Okay, so what you will get is Q minus P. Okay, so these are all the properties. All these properties can be very easily proved using Venn diagrams, or you take example sets and then try to apply them. You can prove it very easily. Okay, let's get into the problems. In a bookshop survey of 100 people, it is found that 35 people like book A, 36 people like book B, 30 people like book C, 10 people like both A and B, 9 people like both B and C, 8 people like C and A, 3 people like all three books. Okay. So, yeah, there are two questions here. Number of people who like at least one book, number of people who like exactly one book. Okay. All these problems, unless until asked, okay, there is no need to do in a stepwise method. Okay. A Venn diagram is the best way. Okay. If it is a question where solution it can be, I mean, if it is a multiple choice question, only answer is important. Just draw Venn diagram. It is very, very easy. Okay. I will explain both the ways, but you can decide which is easy for you. Okay. So this is the Venn diagram. It is very clear from the problem that three of them are interacting, I mean, overlapping each other. So ABC, and this rectangle is my mu. Okay, universal set. So out of that, first start with completely common. Three people like all three books, right? So put it in the center. Three people like this. Then eight people like C and A, correct? Eight people like C and A. So that means five people likes only C and A. Okay. 5 plus 3 is 8. This total is 8. Okay. That's what he's trying to tell when he said 8 people like C and A. Okay. But out of that, 3 are already in this. So 5 people here. Similarly, 9 people like both B and C. So 9 minus 3, which is 6 here. And then 10 people like A and B. So 10 minus 3, which is 7 here. Now we go to the individual one. Okay. 30 people like C, correct? So 30 minus 14. 30 minus 14, which is 16 here. Okay. And then 36 people like B. So 16, right? Uh, 36 minus 16, which is 20. And 35 people like A. So 35 minus 15, which is 20 here. So now you have all the numbers here. Now look at the questions. What is asked? You can answer any question. Number of people who like at least one book. Okay. At least one book. How many people? Okay. At least one book is, okay. You see here A union, B union, C. Correct? Right? So which means sum of all these numbers. Okay. So that is 20, 30, 50, 61, 77. This is the total number. Right? And number of people who like exactly one book. Only one book. Okay. That is here. 20 plus 20 plus 16. 56. Okay, so this is the easiest way to do these set problems using Venn diagram. So if it is a multiple choice question, choose, or if there is no mention of how to solve the problem, you choose Venn diagram method. If they ask you to uh, solve it using properties of sets, then this is how you will do. Okay, number of elements in A intersection B intersection C, same thing, you will just put it in the properties. Okay, and only number of elements in A intersection C, only A intersection C equal to number of elements in A intersection C minus all three, right? So that is 8 minus 3, which is 5. So this is how you will write exactly same way, but you just put it in text way. This is definitely a long method. So easiest is Venn diagram as I mentioned. Okay. And n of A is equal to n of A minus n of A intersection B minus n of A intersection C. Okay. Plus n of A intersection B intersection C. So this way you can find out all the values exactly. As I said, Venn diagram is the best method. Next, A, B, C are sets such that A is not equal to 5, B is not equal to 5, which means they are uh, non-empty sets. Okay. A cross B union B cross A equal to C cross C, which is given. What is the relationship between A, B, and C? Okay. So by definition, A cross B is x comma y such that x belongs to A, y belongs to B. Okay. So since A cross B union B cross A is equal to C cross C, uh, A cross B is subset of C cross C. Correct? Because it's a union. C cross C is a union of two sets, which is one is A cross B, other one is B cross A. So A cross B is a subset of C cross C. That means, okay, A cross B is a subset of C cross C. So x comma y, x belongs to C and y also belongs to C. Both belongs to C. Correct? Because it is subset of C cross C. So similarly, B cross A if you take, okay, both the elements belongs to uh, C cross C. This shows that A and B are contained within C. Okay. Let's say there is one element K comma K which belongs to C, C cross C. K comma K belongs to both A cross B, right? Or B cross A. One of them it belongs to. If it belongs to, let's say one of them, A cross B, okay. So K belongs to both A and B. It is present in both A and B. So if you take any element which is present in C cross C, like K comma K, which tells that these elements is present in both A and B. Okay. So the only possibility for this one is A equal to B equal to C. Okay. You can take very easily using some sets actually. Example, if you take A equal to 1, B equal to 3 and C equal to 1 comma 3. Okay. Then A is equal to 1 comma 3. This is the only option. Okay. You try taking example 1 and 3. So Cartesian product will become 1 cross 3 1 and union of 3 cross 1. Correct? So C has to be, if you take 1 comma 3, then what are the possibilities? 1 comma 3 is possible. One ordered pair. Second ordered pair is 3 comma 1. Third ordered pair is 1 comma 1. So 1 comma 1 is not present in this, right? 1 comma 1 is cannot come from this. Okay? And 3 comma 3. 3 comma 3 also cannot come from this. Okay, that means it has to be same set. You take this example A equal to B equal to C 1 comma 3, then you will find out this is true. Okay, next, let A and B are two finite sets such that there are exactly 144 sets which are subsets of A or subsets of B. Find the number of elements in A union B. Okay, this is a IOQM problem. So interesting. Let A contain X elements and B contain Y elements. Okay. So how many subsets? Common elements are Z. Okay. So total subsets of A are 2 power X. Okay. The total subsets of Y are 2 power Y. Okay. Common subsets of A and B are 2 power Z. Okay. So 2 power X plus 2 power Y minus 2 power Z is equal to 144, right? These are the common elements, right? Union, we are talking about union. A union B is number of elements in A plus number of elements in B, okay, minus number of elements in A intersection B. Okay, so this is number of subsets in A, number of subsets in B minus number of common subsets, okay, which is equal to 144. Okay, this is what we should get into the equation method. Now, how to solve this problem? Okay, we need to find A union B, correct? So, if I really look at the 2 power x form, okay, all of them are in 2 power x form, right? Okay, so only possibility I can see is 128 plus 16, 128 plus 16. This is the only possibility which I can see, which are 2 power x terms, correct? So which means 2 power 7 plus 2 power 5 minus 2 power 4. Okay. 128 can be written as 2 power 7 plus 2 power 5 minus 2 power 4, which is equal to 154. This is the only possibility. Okay. So with this, I can get my values x equal to 7, y equal to 5, and z equal to 4. So number of elements in A union B are x plus y minus z, which is nothing but 8. So there are 8 elements in A union B. Okay. Hope you understand. This is the Avogadro problem. So little bit tricky, but I think very interesting problem. Next, wavy curve method. Okay, this is one of the important method in sets actually. With this, we actually find the a range or set of solutions for a given inequality. Okay, so this is most important method to learn from the sets chapter. I'm definitely every competitive exam will have some problems based on this. Okay, so don't do mistake. I will also I will give few examples here, but more examples I will do it in my charts. Every problem from textbooks I will take, and even though whether it is easy or hard, I will try to put it in the charts. Okay, so keep watching charts also for this method. Only thing is you should not make mistake in this. Once you know this very simple method, learn it, don't do mistake. Okay, so how do you normally find the range of such a expression inequality? X minus 1 whole power 9, x minus 3 whole power 10 divided by x plus 1 whole power 4 into x minus 6 whole power 3 less than or equal to 0. How do you find the range of this one? Okay, so let's learn step by step. Okay, uh, wavy curve method is the method with which we can easily solve such problems. Okay, let's start with a very simple problem. Let us find the range of x minus 1 into x plus 2 into x minus 3 less than 0. How do you find this? You basically put minus infinity to infinity. These are the three roots possible, correct? Put it in the increasing order minus 2, 1, and 3. These are the three roots possible for this inequality. Okay. Now you check at each domain whether the solution is positive or negative. Okay. So that is 3 to infinity when x value is between 3 to infinity. So let's take example 4. If you take 4, this expression x minus 1 into x plus 2 into x minus 3, okay, this expression will become positive. Okay, correct. So I put positive here. Between 1 and 3, that is, let's take example 2. Okay, if I take 2, 2 minus 1, 2 minus 1 into 2 plus 2, positive, positive, negative. So it will become negative. Okay, LHS side is negative. Between minus 2 to 1, you can take a 0 and try. Okay, you will get positive. Then minus 2 to minus infinity, take some bigger number, minus 3, minus 5, something. You will know it is minus. Okay. So now you are looking at this LHS side should be less than 0. Where it is less than 0? So I know the range. Range is between minus infinity to minus 2. Okay. And 1 to 3. These are the two ranges where this LHS is less than 0. This is my solution. Correct. And important thing, note down this bracket. Okay, bracket is like this. It means minus infinity, always infinity you will not put a square bracket. Okay, you will put only this one. Okay, but whereas minus 2 is not included, minus 2 is not part of this one, because if you put x equal to minus 2, this will become 0. Correct, 0 is not less than 0, 0 is equal to 0, so this is not covered. Okay, so minus 2 is not part of this solution, which means union with 1 comma 3. Here again 1 comma 3 are not solutions, but anything between 1 comma 3 is a solution. It can be any real number between 1 and 3. Okay, so this is how normally we write the range of a given inequality, correct? Or the solution set of a given inequality. But let's take, if this is such a complex expression like this, okay, then how to do this, right? So this is where we take the help of wavy curve method. I will explain same problem first with wavy curve method, then we'll go to the complex problems. Okay, so same problem. We'll draw same. We draw minus infinity to infinity. we again put the same roots of this zeros of this inequality. Minus 2, 1 and 3. This is where it becomes zeros. Okay. And now first you will always start from the left side. Okay. So that is 3 to infinity here. You always start from here. Take any value here, 4 or 5, and see what is the expression. Is it positive or negative? Okay. It is positive. So you put it plus. So your wave starts from top. Okay. Wave comes from top like this. Okay. Now, between 1 to 2, what happens is at 3, correct? At 3, 1 to 3, sorry. 1 to 3 is next solution part. At 3, what happens? 3 has what is the power? Power of x minus 3 is only 1, which is odd number, correct? So, we have to consider two things. If the power of expression is odd, then change the curve direction, okay? If the power is even power, okay, power of the term is even power, then don't change the direction of the curve. Okay. So which means it is on the top. Right now curve is on the top. Since this is odd number, x minus 3 power 1. 1 is odd. Okay. You change the direction of the curve and take it to the bottom. So it will become like this, bottom. Okay. Right now there is no filling. Okay. Just assume that this is a just a curve. Okay. Line. Okay. Now at 1 what happens? Again 1 is here, x minus 1. Again power is 1. So curve will change its direction. Now it will go up. Okay. Up like this. Okay. Now at minus 2 what happens? Minus 2 also power is 1. So odd. Odd means change the curve. So it will go down. Okay. So you draw a curve like this and now you know above 1 is positive. I mean greater than 0. Below 1 is less than 0. Correct? In a graph. So for you, you are looking at less than 0 values for less than 0. So that is range is this one. Okay. This is the range for me. Okay. So my solution set is simple. Minus infinity to minus 2. Okay. Exclusive basically. Union 1 comma 3 exclusive. Excluded. Okay. 1 comma 3 excluded. So this is how you apply the wavy curve method. Okay. So let's solve some more problems, then you will easily understand and you can correct all your mistakes. What you do first, you solve it yourself the problem, then check my explanation. Okay. Now let us apply this wavy curve method on a complex inequality. Okay. The one which we mentioned actually in the beginning. Okay. So x minus 1 to the power of 9 into x minus 3 to the power of 10 divided by x plus 1 to the power of 4 into x minus 6 to the power of 3 less than or equal to 0. Okay. So one thing you note down, whether the term is in numerator or denominator, you actually do exactly same thing. Okay. You don't do anything different. Okay. Only thing is you make sure that the denominator terms, okay, doesn't get 0. Okay. Denominator becomes 0 means expression is undefined, right? So don't include those values where denominator uh, becomes 0. Okay. That you should take care. Okay. So again, starting with same minus infinity to infinity. Okay. And then these are my potential zeros of this inequality. Minus 1, 1, 3, 6 zeros of this polynomial are roots of this expression. Okay. Okay. Now, between 6 to infinity, what happens? 6 to infinity, positive, 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 positive. So positive be positive, you will get positive. So it is positive side, it will start from the top, curve will start from the top. Okay. Now, at 6, what happens? At 6, the power is 3, correct? So, the curve will go down now. Change the direction. Okay. Now, at 3, its power is 10. So, no change in direction. So, it will bounce back like this. Okay. Now, at 1, what happens? At 1, it is power 9. So, it will change the direction. Okay. And at minus 1, its power is even 4. So, it will bounce back in the positive side only. Okay. So this is the curve for me, and I am looking at less than or equal to 0, which means the bottom one is my solution set between 1 to 6. Actually 1 to 3 union 3 to 6, which is nothing but 1 to 6. Okay. This is my range or solution set. Here I am telling 1 is inclusive. Actually both should be inclusive because it is less than or equal to, but 6 is where I get denominator 0. Denominator will become 0 at 6. Okay. So I will exclude 6. So anything between 1 to 6 inclusive of 1 basically. Okay, this is my solution set. This is how you solve it. So you can look at how complex this expression is and then how easy my solution is, right? So this is a very good method, either people preparing for Olympiad or for the uh, uh, 11th and 12th and engineering entrance exams, IIT JEE. I'm definitely, you can expect at least one question from this method. Okay, so don't do mistakes. That's all. Let's see some more examples. Okay, now here the range of this one, x into x minus 2 into x minus 5 divided by x plus 3 whole square into 15 minus 2x to the power of 5 less than 0. I choose this example because here you have something different, correct? It is 15 minus 2x. It is not always starting with x and this one, correct? And it is 2x. It is not x. So what you should do in this? Okay, you will rewrite first. Rewrite the expression. Remove the negative. Okay, and as well as always make it x minus something or x plus something. Okay, so I will rewrite this as x into x minus 2 into x minus 5 divided by x plus 3 whole square into x minus 15 by 2. This will become x minus 15 by 2 whole power 5. And a negative sign here actually changed my less than to greater than. Because I removed the negative sign, the expression has become greater than. Okay. So first you rewrite it like this, and now you do exactly same thing what you are doing before. Minus infinity to infinity. Okay, and my zeros are minus 3, 0, 2, 5, and 15 by 2. Okay, at 15 by 2, between 15 by 2 and infinity, that is, let's take it 10, number 10. So 10, positive, 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 all are positive. So it will start from top. Okay, curve will start from top like this. Now at 15 by 2, what happens? It is power 5, hard power, so change direction, correct? And at 5, it is power, again odd power, so change direction. Then at 2, it is odd power, so change direction. At 0, that is at x, okay? Odd power, so change direction. Then at minus 3, even power, so don't change direction. Okay, it will bounce back. So this is my expression, and I am looking at greater than 0, so which is all the top ones are my solution set. Write it properly. Okay, my solution set, and check the division by 0 condition for minus 3 and 15 by 2. Okay, these two should not be included, correct? Even if you have it is greater than or equal to 0, still we should not include 15 by 2 and minus 3. Okay, so my range is minus infinity to minus 3. Okay, exclusive. Okay, minus 3 is not included, so I'm fine. Union with minus 3 to 0. Okay, I cannot make it minus infinity to 0. In that case, minus 3 is included. So I have to break it. Okay, and I have to exclude minus 3. That's the important things to note down from this problem. Okay, union with 2 to 5. Okay, 2 to 5 non-inclusive because I have only greater than basically. Okay, not equal to condition. Union with 15 by 2 to infinity. And here also 15 by 2 should not be included. So it is not square bracket. Okay, so this is my range for this expression. Okay, this inequality. This is a solution set or range, whatever you call, right? Yeah. Next. So another problem can come something like this. Okay. So in this problem, you normally tend to do mistake very easily. So first I want to show you the mistake and then show you how to do this problem correctly. Okay. So you do normally 2x divided by 2x square plus 5x plus 2 greater than 1 by x plus 1. So you take x plus 1 to this side, multiply 2x into x plus 1 greater than 2x square plus 5x plus 2, or if I simplify it, it will become 3x plus 2 is less than 0 or x is less than minus 2 by 3. Okay, this is very easy to tell. The solution set is correct, minus infinity to minus 2 by 3. Okay, but this is not the complete solution range. Okay, we are missing actually the terms which are here, x plus 1. Minus 1 should not be a part of this solution, correct? And something, if you expand this, you will know a few more actually, which should not be part of this solution. Okay, so this is not complete solution set. So another way is you may try to do this way, right? 2x into x plus 1. I took x plus 1 to other side, okay, greater than 1, and I took 1 here, so it will become minus 1. So I take LCM and do this, okay. Now this is what I get actually, okay. So this is my final inequality, okay. The only mistake I have done is this is more or less correct, but I missed my x plus 1 term. If I solve with this wavy curve method, I am not taking care of x plus 1. X equal to minus 1 is not a solution set. I am not taking care of that with this expression, right? So don't do any mistake. Don't miss any of the terms. In wavy curve method, make sure that all the terms are captured. That is most important. Okay. So what is the right way? Okay. The right way is here. What I will do is, this is the given expression. I take 1 by x plus 1 as it is to the other side. So it will become 2x divided by 2x square plus 5x plus 2 minus 1 by x plus 1. Okay. So it will become 2x, and I have to take LCM now. I took LCM. So my denominator covers everything now. Correct? Because x equal to minus 1 is not a solution. That should reflect in my solution, right? So now if I take LCM and then do this, 2x into x plus 1 minus 2x square minus 5x minus 2, I am left with minus 3x minus 2 divided by 2x plus 1 x plus 2 into x plus 1 greater than 0. Or if I take the negative thing other side, it will become x plus 2 by 3 divided by x plus 1 by 2 into x plus 2 into x plus 1 less than 0. Okay, this is my complete solution where I should apply my wavy curve method. What is uh, different from, let's say, previously done here? X plus 1 is missing here, correct? So that is what I have taken care here. Okay, x plus 1 has come here. Okay, so now you put minus infinity to infinity. I have four zeros at minus 2. This is minus 2, sorry. Minus 2, minus 1, minus 2 by 3, and minus 1 by 2. Okay, I think these two should be, yeah, minus 2 by 3 is bigger than minus half actually. Yeah, so this, yeah, this is the right way. Okay, so at more than minus 1 by 2, that means I can take simply 0. Okay, if I take 0, this expression all become positive. So positive, so starting from top, curve is starting from top, and at minus half, that is here, power is 1, so curve is downward direction. At minus 2 by 3, power is 1, so it will again change direction. At minus 1, again change direction. At minus 2, again change direction. Correct? Now I am looking at less than 0, so bottom ones are my solution set. So make sure that my conditions I have to take care is these three should not be part of the solution set. Correct? So minus 2, this is minus 2 actually. So minus 2 to minus 1, and minus 1 is excluded, and minus 2 is excluded. So even if it is less than or equal to 0, still I will write it like this. Union with minus 2 by 3, comma, minus half. Again, minus half is excluded for sure. Okay. This is my solution set. Okay. Next, one more problem we'll do. So find the common solution for such problems also can come using wavy curve method. Only thing is, I just choose this problem because it's a variety. You have to just individually get the solution set, and then take the common solution set. That's all. Very simple. Okay. So for this one, first I will do x minus 5 into x minus 1 into x minus 15 is less than or equal to 0. Draw it. Okay. 1, 5, 15 are my zeros. So 15 plus is always positive. So I'll start from top. Okay. Go bottom because all are power ones actually. So change. And I am looking at less than or equal to 0. So this is my solution set. If I put it in words, it will become minus infinity to 1 inclusive. Okay, inclusive here because it is less than or equal to infinity. You never put a square bracket. Always it is a curved bracket. Okay. So union with square bracket 5 to 15 because it is less than or equal to, I have to include these values. Okay. So this is my solution set for the first problem. Now go to the next one. Okay, same thing. 3 and 10 are my zeros. Obviously, more than 10 it is positive value. So start from top. Then at 10 basically power 1. So I'll change. At 3 again power 1. So I'll change direction. So this is greater than 0. So these are my solution set. This is my solution set. Minus infinity to 3 union with 10 to infinity. Sorry, I should not put square bracket here. Actually, I should put normal bracket. Okay, this is how I should put. Okay, now this is my other solution set of this sorry, this first expression x minus 5 into x minus 1 into x minus 15 less than or equal to 0. Now you just find out from this the common solution set, which is minus infinity to 1 union with 10 to 15. Again at 15, I should not keep this. Yeah, 15 is inclusive. Yeah, that's fine. Okay, so this is how you solve the problems for Wavy curve method and to get the range of given inequality. So yeah, that's all. Thanks. These are all the important topics to cover in sets. I will do more problems. I will take up all the engineering entrance questions in shorts as well as in another videos also I will make for the complex problems. Okay, keep watching them. I will start making other videos for other lessons. Thank you.